Shubhajit Ghosh from Professor of Computer Science Department, Manav Rachna University. And welcome you, sir. It's a pleasure to have you with us. And
yeah, good afternoon.
Thank you. It's a pleasure to have you with us, and we are looking forward to so much of inputs from you. And we think that you would be able to literally guide the people today on the path ahead of how the industry could probably benefit from the application of the industries. Now, a little bit about Professor Ghosh needs to be given. Professor Ghosh is a doctorate in computer science engineering. He had done his computer science engineering masters from the Northeastern University, which is a Government of India university. And thereafter, before that, he was also he did his graduations. He did his graduations and masters from Jadavpur University, and thereafter he moved on to do his PhD from the Northeastern University, and it's been being a pleasure to have him with us. He has with him a post-doctoral experience of more than 36 years in the academics, and he has worked with different organizations like the Lingayas University, Galgotia University, Echelon University, and currently he is the professor of computer science engineering at Manav Rachna University. He has more than 36 publications and to his credit in different journals. He is a man of world repute, having traveled globally, including parts of Africa and other parts of the nation, to promote, project, and help students and eager learners on the technology available in the global market, in the global arena on data and artificial intelligence. So, Dr. Ghosh, welcome to you, and it's a pleasure to have you with us. And we are looking forward to some exciting inputs from you in this domain. Dr. Ghosh.
Okay. Okay. Thank you, Dr. Shivshankar, for the wonderful glowing introduction. Hello, everyone. Good afternoon.
Good afternoon.
So, I'll try to upload my slides. Let me see the slides.
Are you able to share the slides, Professor Ghosh?
Yeah, I'm trying.
There's a share button at the bottom.
Yeah, I saw that, but there's no way where this upload thing is there.
No, you just have to probably press the share button.
No, but the file is in a specific directory. How do I retrieve it from that directory?
You bring it on a PowerPoint mode.
Okay, open that file.
Open that file and put it on full screen PowerPoint mode. Dr. Ghosh, are you there? Can you hear me, Dr. Ghosh?
Yeah, I can hear you.
Now,
I
have
can hear.
you taken the screen, taken the PowerPoint on screen?
That's what I'm doing, but some other applications.
Press the share button below.
Somehow the screens, it's not sharing actually.
No, press the
I
share button.
So it's not showing it. Uh,
Press the share button. What is coming?
no, I've opened the PowerPoint presentation and
Now
within.
minimize that. Now minimize that.
Okay,
Now
I
come
did,
back and press the share button.
which I did. I had pressed the share button only.
So when you press the share button, what is coming?
Sorry, sir. This is, I don't know, on my desktop, I'm getting some, I can see our screen only, the screen where you and me are showing, as
No,
well
just
as,
minimize it. Just minimize it. Reduce
uh,
it. Right and
but,
top corner.
but here that minimize button too is not appearing.
So press the escape button.
Yeah. So, so So
You can see
will
the
I?
slides and continue with the program. And
Ah,
like Professor
okay,
Snehashish, you can also mail me the PowerPoint, which I'll
okay,
circulate
okay,
it to all the participants.
okay. Right, right, right. That
Please
will
go
do.
ahead, sir.
Okay, okay. So the broad talk is on application. Today's talk I have based on application of business intelligence and artificial intelligence in the industry. So my broad talk would include introduction about business intelligence and technologies that we associate with business intelligence, the tools that one uses for doing business intelligence. I provided some simple illustrative examples such as on data visualization, on clustering and customer segmentation, on social media analytics. And broadly and lastly, I have covered briefly the use of artificial intelligence in the MSME industry, which is the micro, small and medium enterprises. So
Okay.
starting with the beginning, what's business intelligence? So it's defined something like business intelligence leverages softwares and services to transform data into actionable insight. Now, these four terms are important here: software, services, data, actionable insight. Now, software is something we all know. It's some sort of collection of instructions and data that tell computer how to work. Services would be a means of delivering value to customers by facilitating outcomes. Data is, yeah, hello, yeah,
Go ahead. Go ahead.
yeah, sure. So data is a collection of facts, some such as numbers, words, observations. Data can be either qualitative or quantitative. A qualitative is data is something that describes something. Quantitative is basically based on some numerical information. So the final thing is, what are actionable insights? So they are basically some direct meaningful actions that can be taken when we analyze the raw data. So how do we get these actionable insights? We do some kind of data analytics that provides us with enough data for organization to make a well-informed decision. If one talks about business intelligence, one has to know some basics like what is data, what are the types of data. These days, data can be of. In earlier days, we had only numeric data in the form of numbers, but these days, the most entire data can be of images. Data can be in the form of videos. Data can be in the form of text. And generally speaking, about 80% or more of the data that exists in the world is in the form of text. So, and that's a challenge, and analyzing textual data. Now, there's some, when we talk of data, there's also a term associated with data, which is information. Now, there's a slight difference between data and information in the sense that data is something that is raw, which is generally collected from a particular source. So when some kind of processing, some kind of computation is performed on that data, we get what is known as information. An example would be, suppose I have some data about students of a particular class, say about 60 students data and the grade card. So I do not know whether the class is a good class or a class of bad students. So if I have to interpret that data, I would do some kind of processing, like categorize the students based on their performance into into say whether the students have scored average marks, or students have scored very good marks. So based on that, based on which side the numbers are bigger, so we can infer that the particular class is good, or the particular class is not so good, and then accordingly the instructor can deliver his or her lectures in tune with the quality of students. So the inferring that was done on the raw data of students, that would be information. Now we're talking about business intelligence. So business intelligence as a process, it can be free, but there are tools which allow you to automate the process. Such tools would require investments. Now, areas where business intelligence can be used in small businesses are say for external areas, you can use business intelligence for market research, for analyzing of competitors, analyzing of suppliers, different products, analyzing different products, analyzing of new technologies, and those were areas where business intelligence were used for external areas. Now, even in internal areas of businesses, business intelligence finds applicability in areas such as inventory control, in best-selling products, in sales comparing, analyzing customers, cost analyzing, operational analyzing, and so on. Now, what are the steps to design business intelligence? There are a few basic steps. Those would be: identify the need for business intelligence. Suppose you, as an organization, you want to track and analyze what is it that would improve your decision making process. So is there actually a need for business intelligence in the organization? So first step is identifying the need, and the second step would be collecting the information. So sources can be both from inside and outside your business. Now, if you want to track your inventories, you would require information from inside your company. But suppose you are trying to track your competitors, so those kind of information would be outside your business. So maybe through internets, newspapers, magazines, blogs. So that's where you have to scan those information that lies in the external world, and then arrive at some kind of decisions about your competitors. Thereafter, when you have collected those informations, you need to analyze those collected informations. At the end of this analysis phase, you come to some kind of conclusions, and then you extract that knowledge. And the final step in business intelligence would be the implementation of knowledge into the decision making. This is a kind of never-ending processes of business intelligence. As you can see, this process doesn't require additional tools. However, the process of collecting and analyzing of information can be simplified if we use IT tools in the processes. Excuse me. So if you collect a big amount of data, it's naturally very time consuming to analyze them and extract knowledge. So, and in many cases, this data may be in text format or something. So there are a lot of challenges. So the challenges of business intelligence is that these days, the challenges for all business is that disruptions are coming in the form of machine learning, artificial intelligence, big data analytic capabilities. These are the capabilities that the organizations, the businesses must equip themselves with. So, so business need to access and apply intelligence in the next 5 years to also, maybe in the next decade or so, to continue to expand. And fortunately, there are some new online tools and specialist business intelligence startups. They are filling the current capacity and capability gaps in this space. The crux is basically that you start with the process, and that would increase your business value, and then once you start with the process, after some period of time, you'll see the possibilities of to invest in some kind of business intelligence solutions. Now, who are the people who are responsible for bringing in business intelligence in an organization? So there would be people like business intelligence analysts, the managers, then the system analysts, programmers, developers, database ERP administrators. A lot of people, technical people, as well as managers, they would be involved in the work of business intelligence in an organization. And though earlier business intelligence was mostly based on technologies such as management information sciences and things like that, which were not too technical, but these days, with so much of technological development, we have to have a knowledge about the technologies that are associated with business intelligence. So business intelligence, knowledge about business intelligence would start right from databases, about how data are stored. We know that database technologies has progressed from file systems to databases. Then the models like relational hierarchical model, and then came the most popular model, which is the relational database management system. Now, why the relational management database management system became popular is because of the user-friendly SQL. SQL stands for the structured query language. So it's a very user-friendly language where users use the query language to make some queries to the database, and results can be retrieved from those databases. So those were the initial technologies. So one, knowledge about business, you need knowledges of databases, you need knowledges about data warehouse. Now, what is a data warehouse? Now, data warehouse is what is the difference between a data warehouse and a database? So database is also contains information. Data warehouse is also a sort of database. But where the difference is basically databases keeps operational data, day-to-day running of data, and data warehouses has historical data which is used for business strategic business planning. Now it's a separate data. Like to give some kind of an example, like you see that a bank like, say, State Bank of India has about maybe 5,000 branches across the country. Now, each of these branches have their automated branches where there are computer systems on which the daily load or the operational load is being handled by systems that are known as OLTP system, online transaction processing systems. But these kind of systems are useful for day-to-day operations. Now, when business needs to make decision, they need to have a separate kind of repository of data, and that would be a data warehouse. So what would a bank like State Bank of India data warehouse would do is that it would pull in data from all the 5,000 branches across the country, the business revenues that were generated, the performance of a particular product, maybe an insurance product or whatever fixed deposit product. And then all this data would be pulled into the data warehouse, which may be somewhere in say Bombay or in Delhi, a huge server. Now, when I pull in data from all the, say, more than 5,000 branches across the country, there'll be a lot of issues involved. So these issues in a data warehouse would be handled by what are known as ETL tools. ETL stands for extract, transform, and load loading tool. So it's a now extraction is taking in data from all the various OLTP system in the branches of, say, State Bank of India, and then transforming would be, say, putting into some kind of a consistency when we are storing that data in the data warehouse. And loading is, since we load all the data in batch, means say in batch means we collect data, we stack data, and then load it in the data warehouse. So this is actually not a very critical from the perspective of business. That is why all these data warehousing loading operation is done during non-business hours. So and then this data warehouses has data warehouse architectures, which are basically the star, snowflake, fact constellation schema. The databases had architectures like relational model, object relational model. So similarly, the data warehouses have their own architecture, which are the star, snowflake. And then we have also computational tools such as the data cube, which managers use for analyzing business data. Also associated with business intelligence would be concepts like data mining. So data mining is basically,
camera microphone duto on kor.
yeah, okay. Okay, shall I proceed?
Please go ahead, Professor Ghosh.
Yeah, okay. So what's data mining? Data mining is basically finding some kind of interesting patterns that would be useful for the businesses. Now, when we have voluminous data at our disposal, we do not know what might be the intrinsic business value that is concealed in that data. So we follow some technical steps to uncover those hidden patterns in that data. So data mining is basically uncovering hidden information, hidden knowledge from very large databases. There are some steps involved, which are the steps like pre-processing steps, then the knowledge discovery and databases steps, then the data visualization stage, where after that the data, after the patterns that you have found in the data mining process through techniques such as classification, clustering, rule mining, and such techniques, how do you really know that the knowledge that you have discovered through the process, whether that would be useful for your business or not? Those data, those knowledge validations are done through aspects of maybe through data visualization and then knowledge validation techniques. Also associated with technologies and business intelligence would be big data, where many people may have heard about big data. Big data is gigantic size data. Now data of cockpit recorder or database data that is coming in from satellites, image data, or any big data which is even bigger than what we have in a data warehouse. So that would be come under the umbrella of big data. Now, there are certain features associated with big data, what is known as the 5 V's: volume, velocity, variety, veracity, value. So volume basically refers to the size of the big data. The velocity is how quickly the data is getting generated and how much it should be, how quickly it should be analyzed. The variety is the type of data that exists, whether it's text, whether it is audio, video. The veracity would be the sort of authenticity of that data that we have at our hand, because bad data would lead to bad pattern generation. And So, and what is also merit the value of those that data that we are having. So, now also associated with big data technologies like Hadoop and this, which basically are distributed processing architectures. Now, the popularity of the databases were the SQL queries, but with big data, which stores mostly text. We have these concept of NoSQL databases. NoSQL databases like MongoDB, Cassandra. So these are all the NoSQL databases that we have in our midst now. Like Facebook, the social media Facebook uses something called like the Cassandra. Also, would be one needs to have knowledge of technologies like Hive, HBase, Pig. So what I'm trying to arrive at is that these days business intelligence has somehow become quite technical in nature, unlike in the past. So also associated with business intelligence would be AI and ML. So artificial intelligence is basically making machines intelligent, like humans. Like we humans have quite capability to do many tasks uh, in a way which a computer would not be able to do. Like say, we can recognize our friend if we have known our friend, someone like 25 years, 30 years back. We see him after 25 or 30 years, and his face has changed completely. Now if you give a computer to recognize the face and match it, the computer would say no, these are different faces. But humans have the capability to detect such variations, and you may even you'd be able to say identify that he's your same friend that was the in is from the past. So there are certain tasks which human beings are quite good at, and these tasks, these things that we are good at, scientists, that is the main driving force behind a subject like artificial intelligence. How do we make machines intelligent like the humans? And then a subset of AI is machine learning, where we have learning types like supervised learning, unsupervised learning, reinforcement learning. So now, how is learning utilized? Like, to give an example, like say mm, like many things are automated these days in the west, where there is a lot of less manpower, a lot of work is automated. Like say we there are these fish trawlers that goes into the sea to catch fish. So they will pick up those catch, and then they come to the land, and then offload their entire catch on the ground. And then how do you sort those fish that they have actually caught, these fishermen have caught? And are you going to do it manually to sort of segregate the different types of fishes? Because at the end of the day, all those fishes would be put into some kind of jars and sold in the market. So how do you segregate that those catches, those fish? So a lot of automation has happened in there, where we use these learning features. So what would be there is that we put that catch and put it in some kind of a tray, which is then passed through the conveyor system. Now there would be a camera, so each and the fishes will pass through that conveyor, where there'll be a camera which would take a picture of a particular fish. It would sort of analyze the feature of that fish. Okay, where is the position of the eyes? How what is the length of this fish? where is the where is the fins, depending on those features that is being exhibited on the camera, that's being exhibited on the image under scrutiny. So you have the classifier system. You compare the input image with the classifier that you already have, and then once this comparison takes place, the classifier would output the fish and put it into one of the known categories. So, and then basically what would happen is that the image was analyzed and the fish was directed to the appropriate bucket or bin. So that is how automated. There's no human involvement in the entire process. So everything is being done. So that is where the beauty of the AI or machine learning comes in. So, okay.
Got it.
Yeah. Huh.
There are a lot of questions coming in, and it's a pretty interesting topic. And very frankly speaking, sir, people who are online since the morning, they have a lot of queries because there are certain different views by different speakers earlier to this. So we would like to sort of see whether we could put those queries across to you. But before that, we would like you, I have not disturbed you during the presentation because our system is we do not allow anybody to intervene. After you have finished your session, take the questions and put it across to you, sir.
Okay. Right. So shall I continue?
Please go ahead, sir.
So again, after this, we also have technologies like data analytics. So analytics is basically some kind of a systematic computation and analysis of data. So it's something used for the discovery, interpretations, and communication of meaningful patterns. So it's valuable in areas which are rich with recorded information. And the thing is that analytics, it relies on applications of statistics, computer programming, operation research to quantify performance. There are basically three types of analytics: the descriptive, the predictive, and the prescriptive. So descriptive is basically what has happened. When we analyze some kind of historical data, then we come to some kind of a conclusion as to what has happened. Predictive would be, okay, how do I predict what can happen? Like depending on the data, like regression techniques and statistics is a predictive technique, or classification in which is an supervised learning technique. That's a predictive technique. So they will predict as to what can happen. And prescriptive analytics would be what should I do in the case it's some sort of a prescription as to what one ought to be doing. Also associated with business intelligence would be techniques like MIS, which is Management Information System. It's a thing that has been there for quite some time, even before the advent of technology. So much of technology in management decision making. So MIS need informations to make effective decisions, facilitate communications within and outside the organization. So that is another aspect. So Then we have also, as I have said, that with business intelligence also we would have technologies like data visualization. Data visualization tools, they kind of help us to understand trends, the outliers and patterns in data. Trends you understand. Now outliers are basically some kind of value that's a nuisance. Like outliers can be some kind of fraud in any business transaction. So these needs to be identified, so that businesses don't suffer uh, from falling prey into the hands of these evildoers. So, so data visualization tools and techniques, technology, they essential to analyze massive amounts of information and make some kind of data-driven decisions. Also, these days you find that with business intelligence, we have something called the sentiment analysis or opinion mining. So it's a natural language processing technique where which is used to determine whether the data is positive, negative, or neutral. So this is because this is on text data only. And businesses, they like to monitor the brand and product sentiments and customer feedback. So suppose a company has launched a new model of a particular mobile or some product, and then it basically likes to analyze the sentiment or the product or the review of the buyers or users of that product. So that would be sentiment analysis. So basically, those sentiments are either positive or negative or something like neutral. So something like a statement is positive, like if someone says my experience so far has been fantastic, so that may be a positive feedback. And neutral feedback, maybe the product is okay, I guess, something like that. That's a neutral feedback. uh, and negative feedback would be something like, okay, your support team is useless. So that is a kind of a negative feedback. So what I was trying to convey across is that business intelligence, it cuts across so many technologies, so many areas, and one needs to be really spend quite some amount of trying to grasp the technical challenges that exist in this discipline. And also associated with business intelligence would be operation research, which is application of advanced analytical methods to help make better decisions. So now there are tools which are used for business intelligence, like there's a tool called Tableau, which is a visual analytic platform transforming the way we use data to solve problems. Some people, a private, though Tableau is proprietary, but there's a public version which can be used for sort of doing basic visualization. One can download that, it's the Tableau public version, and play around with the different analytics that one can do with Tableau. Of course, it's proprietary, and one needs to purchase for getting all the advanced business features. Also, in tools would be like, yeah, hello. So also there would be tools like R language, which is a statistical and computing language. It's an open source language which are used, and they provide a wide variety of statistical tests. time series analysis, clustering, classification. So these are they give graphical techniques. So R has all of those. And there are so many other tools which are used for business intel, like SAP Business Intelligence, SaaS Business Intelligence, IBM has Cognos, MicroStrategy, Oracle Business Intelligence, Microsoft Power Business Intelligence. So you can see the range of product, business intelligence product that is there in the market. Then one of the very popular language for business intelligence is Python. It's a high-level general-purpose language. It's an elegant syntax. So Python has become a big buzzword in the in AI and data science. Well, while talking about business intelligence, also we should not forget that there's even in Microsoft Office application, there's Microsoft Excel, which is a spreadsheet program which helps you to analyze data. So, so the data visualization, you can do some amount of data visualization even with MS Excel. So MS Excel is an advanced version of earlier spreadsheets like Lotus 1, 2, 3. And for the beginners, one can usually try using Tableau and find out and compute some simple statistical functions like mean, median, mode, standard deviation, variations, regression, clustering. Those are things that a beginner with Tableau can try out. Actually, the next part of my lecture is basically some data visualization. So, there's some, since it is about visualization, there are certain techniques which needs visual. Since I'm not able to somehow show these slides, this would not be very understandable without looking at the slides. So what I would do is that I will send across these slides. So anyone who has some query, they might get in touch with me, and I'd be happy to try and solve their query. Because this segment is about data visualization, and there are a lot of pictorial diagrams only through which it can be explained. No amount of talking can really help here. So similarly, there is also a technique like clustering, which is used in customer segmentation. So clustering is something like when you're trying to learn about something, say music, one usually looks for some kind of meaningful groups or collection. You can organize the music by genre, while your friend might organize music by decade. So it's how you group. So one person groups it by genre, the other person groups it by decade. So how you choose to group those items might help you to understand more about the individual pieces of music. You might find, you might have a deep affinity for a particular kind of music genre, and then further break down the genre into different approaches of music from different locations. So each genre might be from, it may have come from different locations, from different countries. So you can do some kind of analysis through such groupings, through such clustering. Talking about this music example, so even though your friend might have looked at music from the 80s and was able to understand how music across genre at that time was influenced by the socio-political climate, in both cases, you and your friend have learned something interesting about music, though you took different approaches. So this is basically with regard to grouping and deriving some meaning out of those groups. So the different people may have different ways of grouping that same data. So in machine learning, we often group examples as a first step to understand a subject in a machine learning system. So grouping unlabeled example is clustering. What is unlabeled? Unlabeled means there are no training examples given. Uh, Basically, at the end of clustering, what we get is some kind of a categorization. So that those categorization is okay. This kind of this input data belongs to this group or this cluster. Like say, to give a very simple example, like suppose I have a particular organization in which the organization does some kind of analysis, so it wants to categorize all its employees as productive or non-productive. So whatever it's the measure that it adopts. So eventually it for each and every employee in that organization, he is categorized into two categories. One is productive, one is non-productive. So this is basically uh, your clustering. You have been grouped into one of these two categories. So clustering basically gives you those groups, and within a group, all the elements are similar. One thing to note is that if the examples are labeled, then clustering becomes classification. Like clustering is basically unlabeled example, means there are no examples that helps you to find the learning in the, so both classification and clustering, these are learning technique. Classification is supervised learning technique, clustering is unsupervised learning technique. So when I was giving that example of that fish sorting system, I was talking of a supervised learning system. So that is where it involved training samples. So like fishes of certain features, they are given some kind of a label. Okay, if the fish is very long and its eyes is in a particular position, then this is a fish of category 1. Then if the fishes are small and it is its breadth is of this nature, then it is of category 2. So and from that initial label, so those are the labeled examples. From those labeled examples, we build the classifier in classification. But in clustering, we do not have those labeled examples. Like no one would tell you that, okay, this fish of this feature is of this category. Clustering would have to find it on its own. So that is the distinction between clustering and classification, which are both learning techniques in AI. So clustering basically will group similar examples, and they are the similarity is grouped using something called the similarity measure. So these are basically some kind of distance matrix, like Euclidean distance or the Manhattan distance. Euclidean distance is something like a mean root square value of if there are 2 points, say B and C, then the coordinate values of xb minus xc square plus yb minus yb square, if B and C are the values xb and yb, and C is xc and yc. So that is a measure to compute the similarity between 2 points to find the cluster. So uses of clustering would be in social network analysis, in market segmentation, in medical imaging, in anomaly detection. So these are some of the uses of clustering. So Google uses clustering for generalization, data compression, privacy preservation in products such as YouTube videos and music tracks. So those are, and then in clustering, one of the most popular algorithm is the k-means algorithm, which helps to find clusters. Like suppose I have uh, 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 I have a data set of say 50 dogs, and I have their value of width and height. And there is a manufacturer who wants to build, who wants to make sweaters for dogs. Now, since there are 50 samples, so would he make those product in 50 different sizes? That is not business. That does not make business sense. So
Absolutely.
what this person would do is that he would make maybe three such sizes. And how do
Right.
you arrive at those sizes? So you basically take those data set and put it into three categories. So they would be the three clusters. Now those three clusters are basically groups of similar points. And how would the cluster be characterized? Each cluster would be characterized by its mean value or the centroid value. So eventually those 50 points or those 50 dogs would be represented by three groups, and the centroid or the mean value of those three groups would be picked up, and then that would form the size of the sweater for the dogs. So that's what technique like clustering has a lot of business applications. So this is just to give you some idea. Similarly, in analytics also it is done, but
Carry on, Dr. Saab.
hello.
Please
Yes.
carry on.
Okay, right. Actually, right now, okay, then I'll give you a brief idea of how AI is being used in the industry. I'll just look into some ways in which AI will benefit the Indian MSME sector in say 2021. So the view that earlier that advanced technologies like AI and ML were unaffordable and only serves the need of large enterprises with very deep pockets have now become redundant. Why this? Why? Because there's a proliferation of large-scale digital marketplaces. Everything is being done over e-commerce, and a lot of data is getting generated about business transactions and the buying patterns of customers. So earlier, people used to feel that okay, technologies like AI and ML were unaffordable, but right now because things are moving digital on the digital platform, so one needs to invest in these technologies. So how these digital marketplaces, they are leading the way in transforming the tech challenge MSME sector to full-fledged digital enterprises. And now with technologies like cloud and things like that model, it is easy to pay for models. Like you don't buy an entire system, an entire heavy compute, a very costly computer system, which are known as, say, servers or this thing, costing in lakhs. You can buy some space in the cloud, or use some application on a pay-by-use model, what is known as cloud computing. So that entire, it makes business revenue. It makes sense to pay less for. Suppose I, as a user, I need to use very less amount of a particular software. Say I use very rarely, say, Microsoft Word to make documents. But if I buy a legitimate software like Microsoft Office, it costs me a lot of money. So if that same thing is available on the cloud, and I pay some amount of money to a company which is offering that service, in lieu of that, with some amount, with little amount of cost, I can get my job done. So that is the best part of those models. So 10 top ways in which the tech-led digital marketplaces will leverage AI to transform the MSME sector. One would be the conversational commerce. You see, the AI-based conversational interfaces is in demand very lately. So it's something like everyone likes to, customers like some kind of personal care or something like that. Like, where is my order? So the buyers, they want some kind of instant gratification. So from routing customer service requests to tracking packages, personalizing product suggestions to handling returns. So AI can offer solutions in many cases before customers even ask questions. So this is very, very essential for the modern day consumer. So conversational commerce is one area where it would help the MSME sector. So platforms can initiate price negotiations, catalog displays quickly, offer smart invoicing, AI-assisted chat interfaces. These are just some of the things in which efficiency and productivity can be brought out into the whole MSME segment. Better access to finance. Second would be something like better access to finance. Earlier, MSME sector was one of the most credit-starved in the world, with only 4% of the sector availing formal financing, thus inhibiting its growth. So this was why the reason was the lack of traditional database data sets in this sector. So one robust use case of AI ML on platforms or digital ecosystems is improving access to unsecured loans to small businesses, because these credit products are built using alternate credit scoring models. So financial institutions can trust to make credit decisions, lending to small businesses at minimal servicing costs. So these are one area where AI ML technology is helping this sector. Then product enhancement and customer engagement. So you need to engage the customer, improve the product. So using data from the chatbot platforms, MSME can drive greater customer engagement. This can help in understanding the customer requirements, define the purchasing patterns. So this will allow them to increase or modify the range of product. So analyzing customer feedback with the help of AI-based models would lead to new insights. The other way would be smarter marketing with AI-based technologies. One of the biggest advantages of AI is basically predicting customer behavior. Also forecasting sales. So AI can predict about the possible customer behavior. It can forecast the likelihood of sales. So advanced systems will be able to combine data mining, statistics, sales modeling to predict future outcomes. So businesses can leverage this for segmenting customer, for customer segmentation, building their digital strategies, digital or on the digital marketplaces. So MSME can take advantages of these predictive analysis to achieve leads. So informed working capital planning. So it's also a lot of business wastages can be done away with through technology. Like you see, the use of these modern technologies can reduce operational costs because you are getting more insight from data, which the traditional business model often failed to predict. So AI can foresee and invest accordingly by applying accurate forecasting based on real-time data. Another would be in optimizing operations. MSME using the AI-powered digital platform, they can improve the supply chain and logistic efficiencies for better warehouse management, smarter shipping, inventory upgrades, route optimization, improved delivery. So all those optimization work can profit from the technologies, from the AI and ML technologies. So then identifying new markets. So MSME sector is highly competitive. To keep growing, the companies need to find newer markets. So AI-powered competitive analysis tools available on B2B platform, business-to-business platforms. They help them understand what their competitor strategy are. So then quality control, error reduction. So these are things which would profit. So cognitive augmentation enabled by AI can drastically reduce human error due to a lack of knowledge, because humans are prone to error. But if you can feed that to a machine, intelligent machine, he is unlikely to make errors if the logic or if the rule behind the process is accurate. So that is the machine. That is where machines have an advantage of humans. Like the same work, if you give to a human being, he might do the work. Say maybe. And 95 cases of the time you'll do it correctly, 5 times you may do it wrong. But if a machine does that same work, if it is right once, it will be right the rest 99 times. So machines don't make those errors. So cognitive augmentation enabled by AI can reduce those human errors. Automating workflows. MSME proprietors, they spend almost 50% of their time every day in managing the day-to-day business functions. One is lack of manpower and enabling technology. So automation reduces the need for time spent on repetitive tasks. These days we have technologies such as RPA, the robotic process automation. So these are basically automating the routine and repetitive tasks. So you can automate the workflows using RPA, things like that. Also, finally, in prevention of fraud prevention for a small business like the MSME sector. So getting into fraudulent transaction with unverified or illegal entities is far more dangerous than a large corporate. Because it will lead to severe losses, which would be hard to recover. So technologies like blockchain, pattern recognition system, they help in real-time fraud detection. So this is how the digital trust ecosystem is strengthened. So this is basically the broad spectrum of area that I in related to business intelligence and AI, and AI specifically to the MSME sector that I touched upon. Are we ready to take any kind of queries that may be
Well,
there?
Professor Saab, there are a lot of queries and a lot of interest has been generated. But before I move on to the queries, I would like to mention a couple of facts which are needing to be highlighted before I move into the queries. The fact that you focused on MSMEs, after hearing your presentation right from the beginning till the end till now, I feel that whatever you've spoken for MSMEs is very much applicable to the bigger industries also, including the heavy industries, because the process, the methodology, the tools that you have spoken of, for example, clustering, for example, data analytics, for example, mining of data. Now, these are basically tools which not just the MSMEs who can use it. In fact, currently, right now, we are passing through a transition phase in technology as far as our nation is concerned. And in this transition phase of technology, I think most of the progressive organizations, um, mostly in the private sector, and yes, some of them in the public sector also, are using these techniques. So, for the public who are online right now, which is more than about 300, I am wanting to tell them that before you react to say that I am not from the MSME, so how will it apply to me, or I am not from the small sector, so how am I going to use this, etc. Let me put it across to all of you sitting there and watching this program, that the techniques and the technology are as much applicable to the other segments of the industry, which is the medium industry, the heavy industries, the infrastructure industries, or the power industry, or for that matter, the finance industry. And all these tools and techniques are applicable to them. Correct me if I'm wrong, Professor. I hope I said the right thing to the participants who are online right now.
Yeah, absolutely.
Okay, now I will start taking the questions. The first question has come in from Mr. Sampath Kumar. Mr. Sampath Kumar of NHDC. Now, Mr. Sampath Kumar is General Manager, National Hydro Development Corporation, and he has this very important question, and which I feel I should be supporting him also. When you spoke of predictive analysis, now the question is specific to the predictive analysis. He says that during elections, all the television channels do a lot of predictive analysis, factoring in all the possible variables, emotions, sentiments, market survey, voter survey, and pre-poll survey and post-poll survey, etc. In spite of that, we have seen quite a few number of times, or rather most of the times, that these predictive analysis of the television channel go absolutely haywire, and it is nowhere near the uh, actual results which come out of the elections. Now, let us for 2 seconds, or rather for this purpose of this program, assume that the elections were absolutely free and fair, which I believe it would have been. But if that is the scenario, the question is, how is predictive analysis a good tool to be used in the industry?
Now you see, uh, like if you compare a predictive technique from the perspective, say the election scenario is how do they make predictions? So they collect, they take some sample opinions. So, and there are a lot of sampling techniques, like what is the size of your sample, what is the representative kind of sampling technique you have used, whether you have equal sampling techniques or you have taken samples from certain demographic segment, like whether the groups like male and female were adequately represented, whether particular age groups were represented in those samples, and where was the opinion taken, whether they were taken from the marketplaces, or taken from the individual residences. So when we make these opinions of forecasting technique, a lot of things depends on the data that is there with you. So, and these data may not be the actual representative data in the case of elections. Whereas if it is a company data, the company data forecasting of company issues would be based on historical data. So when I'm making some forecast about some performance in an industry, so that would be based on some data that is correct data that from the past. So in such cases, the forecast or the predictions are most likely to be more accurate than in the case of the say election that you're talking about.
Okay, point taken. That is, probably the variables were not correctly represented, or probably the variables were not sufficiently covered. So there is a huge, what I can understand is there is a huge margin of error between the reality and the predictive analysis. Uh, and possibly that can happen to the industry also, Dr. Ghosh, because, for example, if a say MCB switch, or a circuit breaker traditionally has been giving a life of say 2 years for a power industry from which Mr. Sampath is coming from. So is it good to predict that the next switch gear which I'm fitting today would be giving a life of 2 years, even though the manufacturer is saying that this has a life of 1.5 year, meaning say 18 months, whereas from the same manufacturer I have been buying MCBs which have been giving a life of 24 months. So now the biggest question that comes up in my mind, and probably in Mr. Sampath's mind, is on the basis of predictive analysis, which data should I be taking? Should I be considering 24 months for replacement of that MCB, or should I be considering 18 months for that replacement of MCB from the same manufacturer?
I'm not specifically aware of this. How do they make these guarantees actually? So in the industry, if a
No,
manufacturer is
let me update you on this. They do fatigue test. They do a fatigue test, just like any medicine. When you buy a medicine, it has a expiry period, and as a natural process, as you, me, or probably everybody, when we see that the expiry of that medicine is the medicine has expired on the expiry date, we don't use that medication. But technically speaking, from even from the pharmaceutical industry, where I have personally interacted, I have worked, I can tell you that whatever may be the date given on the expiry, the actual expiry of that particular medication is definitely 2 to 3 months more than the expiry date which is given. But they don't want to take the risk. So within a safety factor, they have a certain safety factor. So they give an expiry factor. Now I'm asking a different question. Forget about the parameters about the manufacturing expiry date. I'm saying based on the tool of predictive analysis, should I take the data of the expiry period of the machine or of the MCB, or should I take the actual experience of 2 years, which was the life of the MCB, for the purpose of replacement?
Look, this is more of a business issue actually. Now, like, say to talk about, say, predictive techniques and its utility, like I gave that example of the automated fish sorting system,
Right.
where so everything is automated. That is a predictive technique, right from the catch, where the fishes are brought into from the sea by trawlers to the land, and then it's put on the tray of the system of the, say, fish sorting system, till the moment where the classifier is sort of categorizing the fish into the different categories, and then from these buckets, these fishes are taken in as product, and they are packed and then sold in the market. Everything is automated there. So these are all based on predictive techniques, and these are all industry level applications. And the
I'm
error,
fully clear on that. But what I'm trying to understand is, today, when the industry is planning to reduce cost, one of the methodologies for reducing cost, which the industry is working on, is moving away from preventive maintenance to proactive maintenance. Now, the proactive maintenance is totally based on predictive analysis, meaning, even though the product defined by the manufacturer has an expiry of, say, 18 months, because of my past data which says that this product does not expire before 24 months, I will use it for 24 months, by way of which I save the resource commitment for 6 months. So that is one way of looking at it. Now, is that a right approach, or is that not a right approach?
that might be on a case to case basis. I guess you might have to see it. Like, say, in the case you said about medicine, they give the expiry date 2 months in ahead of this thing. So since those are
Right.
critical, so you have to see the nature of the product, and how critical, or how what might be the consequences of overuse or things like that. So I guess some kind
No,
of
what I'm trying to say is, supposing we factor in all those data, for example, what happens if it short circuits, what happens if there is an overuse, what happens if I do an overload. So if I factor in all those parameters, will I be able to prolong the actual life of the MCB from the life which is printed on the box, if I factor in those probabilities?
I guess that requires more domain knowledge to really comment, make a
Okay,
very
let's move on to the next question. You spoke about clustering. Now, in the clustering, you also spoke about, say, sweaters or clothes for the dogs. And there are 50 different kinds of dogs. So you clustered it in three categories. Let's put the names on those categories, say large, medium, and small. And the way to cluster it, as you told us, is to work on a central median. And keeping the central median, you told us that we have to
and
define the
normally
size.
one of the very popular. There are several clustering techniques, but a
No,
very popular technique
I'm just going by what you are say, what you explained to us, sir. And you said that, okay, we go by a central median, and we create the dress for, say, small, medium, and large. Now, supposing it's a large dog, and it is categorized in the large category, but he falls on the outermost periphery of the band of the large category. Now, isn't that not a chance that it will probably be tight fitting on the dog?
That sort of problem will always be there, because since in that cases, you see, even when I'm making those three clusters,
Yes.
so in terms of clusters, when I'm making three clusters, what
Mhm.
is a cluster? Cluster is a group of similar things. Now some of the elements, there may be a very marginal difference between the from the mean of the two clusters. So
Okay.
maybe so and there may be a wide difference between the mean as well as to why it is lying in that particular cluster. So
Okay. Now,
there may
so what you're trying to say is the mean has to be very close in nature to the outermost periphery. So either you increase the number of clusters, or you ensure
so
that the mean is close to the lowermost and the uppermost category, so that the mean is actually will service
no
that category in all respects.
say ideally, what is this problem? There are 50 dogs, and the manufacturer wants to make some sweater for them.
Yes,
Ideally 50 dogs, so there'll be 50 clusters,
correct.
and then make for each and every. But since that is not possible, so
Right,
that is why the manufacturer will decide, I want to make three types of sweaters, or I want to make five types of sweaters. If it is five types, then the cluster will be five. If it is say
right.
10, so depending on that.
Okay. So more the number of clusters, lesser will be the chance of overfit or underfit, because
Yeah,
the cluster, the central
yeah,
median will be closer
yeah,
to the outer
yeah,
periphery of the
yeah,
upper and the lower
yeah, yeah.
range. Okay, got
Definitely.
that. We have a question from Mr. Rahul Dio. What are the steps to implement company BI analytics from grounds up?
Yeah. So you see, there's a lot of things. I spoke about technologies like data warehouses and this thing. So you need to build some kind of company analytical storage, data storage, like in data warehouse. There's also a subset of a data warehouse which is called a data mart. So first step is possibly you build that kind of an analytic storage. Then you devise the schema for that. Like for a data warehouse, the schemas, as I briefly mentioned, are something like your fact constellation, or snowflake, or star. So those are the schemas that exist for a data warehouse. So that would be maybe the second steps. Then you have to populate your those repositories with some existing data, and keep on feeding those data from time to time, update it. Then set up some kind of BI tools there to perform those analytics and develop some reports, and keep on say improving on the existing through analysis through. So this is the general way in which
Professor, what is the most popular programming language for AI?
that would be Python. Python
Okay.
is the most popular.
And today, Python is part of a regular curriculum for a CSE student in the universities.
Yeah. Most universities, they are all teaching Python
So
courses.
the fresh pass outs of CSEs would probably be knowledgeable on the Python programming language,
It's
and
quite
they can
expected.
probably use the AI technology for
Yeah.
implementation in the industry.
Uh,
Okay.
uh,
What is the difference between AI, ML, and DL?
Deep learning, AI.
Yes.
Yeah, yeah. Basically, AI is the main. and then a subset of AI is your ML. So machine learning is a part of artificial intelligence. Uh, Artificial intelligence is basically anything that mimics human kind of intelligence. That would be artificial intelligence. But and machine intelligence is a part of artificial intelligence, which basically learns from data. As I was telling you, that unsupervised learning, supervised learning. So those are machine learning techniques. So machine learning is a subset of artificial intelligence,
Right.
and a subset of machine learning is your deep learning. So deep learning is basically it's an extended thing from what are known as neural networks. So neural network were usually one layered learning of unsupervised supervised learning techniques, which came about. It was modeled on how the human brain performed. So an extension of that neural networks into multiple layers uh, came to be known as the deep learning technology.
Okay. Now, let me try and see if I could accommodate one or two more questions. In the machine learning is based on the artificial intelligence, and artificial intelligence is based on data, algorithms, and various analytic techniques, which are collated and fed to the machine, and the machine then analyzes it or uses it for different kind of activities. Now, what I am trying to say is, we have one view wherein it says, without human intervention, without human intervention, these are highly prone to errors. And there is one
Absolutely.
school of thought which says that the digitization or application of artificial intelligence is going to be such that apart from emotions, everything would be automated through the process of artificial intelligence. Now, which of these school of thoughts is the right one? Would you enlighten us, sir?
We're still a long way from reaching what is known as general artificial intelligence. General artificial intelligence is the discipline which concerns with fully intelligent systems able to make decisions without errors. We're still quite a long way out away from that. And I heard the first talk of Dr. Sneha, and he was talking about the human error. Like there are certain things which machines cannot comprehend, or the machine learning is still inadequate to respond to certain intelligent situations, which only humans can. Like I said, like if you give a photograph of, you might recognize your friend even after 25, 30 years, even though his facial features might have changed. But you give that same photo to a machine, so what it would do, it would do some kind of a comparative analysis of the faces, and then in most cases, if there has been some kind of a facial distortion or something, it said that this person is a different person.
But isn't
Whereas
it contradictory, sir? Today, in the school of criminology, or rather in the process of criminology, face recognition is totally done through artificial intelligence, and that's how they identify criminals. The criminals may have grown a beard, they may have grown long hair, or they may be wearing some gowns or anything to cover their face. In fact, just by reading the iris, and it has happened to me also when I was traveling to Dubai, they were able to tell which all countries I have visited. Forget about face recognition. So, if there is
talking
a
about face,
photograph, yeah, please.
talking about face recognition, I think iris recognition is more advanced, and this thing is more foolproof.
Agreed. But even today, the face recognition technique is the most important technique the criminal departments or the intelligence department of various police services and military services all across the world use to identify people and to identify the person who they are looking for through the face recognition of the on the photograph only. So how is it that a
They
human can analyze it better than a person? Because supposing if you
they
were to see my photograph, say about 25, 30 years back, I had long hair, I had no mustache, I was far more obese than what I am today. And I don't know, many people say they can't recognize my current face, whereas the original face was different, but the machine recognizes it, my face. And when I went to a bank for other authentication, the other authentication immediately happened with my face recognition. So which is the one
you
which is
see this accuracy level is very high in the facial recognition system, because they have to pass through a lot of training and score good on the accuracy rate, because any kind of classification or any kind of identification system that you develop, they have to have an accuracy level of 99.99%. So maybe in out of 1,000% they are able to accurately detect 99%, so something like that. So commercial, but there are very minor errors, and I just gave a very random example of human intelligence.
okay.
Why?
Okay. Okay.
That was the genesis of how the subject of artificial intelligence came about in the 1950s, when artificial intelligence generated interest as a subject. So in 1950s, in 1956, the first conference, the Dartmouth Conference on AI, took place. So the theme or the main reason for or the motivation behind that was to make human beings perform tasks that humans are good at. Means machine should be able to do the tasks that human beings are good at. That was the motivation behind the first AI conference.
Right. I think it was in 1950 was the first platform on which the AI was started, but thereafter it
1956.
fizzled out. It literally fizzled out, even though some research here and there were going on, but the activity fizzled out till about 2005, when the machine, or rather the Google machine, Google AI machine, was able to out perform the chess player, Go player. In Go player, Algo was defeated by the machine. Consecutive, Algo was the world record holder for 7 years, and the machine was able to defeat him three times consecutively, and thereafter the machine algo version 2 was able to understand the techniques of the person or the man, and he became the machine became undefeatable. That's when probably people started taking up artificial intelligence in a more serious manner. And today, I think that has been a part of our daily routine in many ways. We even in ways which we don't realize. For example, when we get triggers on the Facebook, when we get triggers on the Google search, or when we get triggers on the Twitter handle, we do not realize that all these triggers are on the basis of the artificial intelligence being collected by these organizations at the back end. Anyway, thank you very much, Professor Ghosh. It's been a wonderful time associating myself with you,
No,
and I and the entire people who are currently enjoined are grateful for the excellent inputs that you have given us. And you've talked about so many different topics, all applicable to the industry. And I'm sure many of them and most of them would have taken a lot of inputs from this presentation, and they would be able to use them. for your kind information, sir. Based on your inputs, we shall be preparing a report and submitting it to the Government of India, wherein the Government of
Right.
India may take a call as to which of these suggestions or the technologies or the techniques that you have spoken of could be probably homologated or absorbed into the government industry. And we are all working towards the new nation or new beginning, because if you see on the global map of artificial intelligence, India ranks ninth, which is far, far lower than the topper, which is incidentally not USA but China. The second in rank is USA, followed by others. But we would like to be reaching there. But the most important fact is your inputs are really going to help the industry increase their profitability, reduce their overheads, and thus give in a better contribution or a far higher contribution to the overall GDP of the nation. Thank you very much, sir. It was a pleasure having you with us. And
Yeah, thank you
I
for
would
inviting me. It was a privilege.
the pleasure is all ours, and it's been great talking to you. Sir, I would like to update you that you, based on your performance and based not on the program, based on your performance on the research front, which you have been doing for more than 3 decades now, we would like to felicitate you tomorrow at the auditorium at Paryavaram Complex. A formal invite has already been sent to you on WhatsApp. We would request you, and if you feel
Okay,
some of your colleagues would like to also join you, all of you are most welcome to come on the location or to the auditorium tomorrow at 2:30 p.m. And
right.
would want to felicitate you. The Chancellor of Confederation of International University, Dr. Priyaranjan Trivedi, would be felicitating you, or Dr. C.P. Thakur, who Minister, would also be there. Uh, Health permitting, he's pretty old, but okay, there would be other member of parliaments, etc., also would be there, and we would like to felicitate you for your contribution in this domain, sir. So we'll be grateful if you come over along with your associates on this particular occasion, sir.
See,
Thank you very
I'll
much.
try my level best. I'll try my level best.
Thank you very much, sir. It's been a pleasure talking to you, and we look forward to more such support from you and to help the nation and the organizations develop more and become real contributors to the government's or to the nation's economy. Thank you, sir.
Okay. Thank you. Yes, thank you. Okay.
Thanks.
May I leave now?